What percent of this black space is being covered up by the circle there? In other words, how many circles can I fit on this design? Let's estimate it. If I move this circle to the edge here, does it cover up more space, less space, or the same number of space units? The answer is it covers up the same amount of space. Whether I put it there, or I put it there, or I put it on the top there, it covers up the same amount of room. So you know what I'm going to do? If I said, let's put it here, let's put another one beside it. And how many can we put all together? You would probably think right now that I can take all of this space here and maybe form a circle. That would make my third circle. I can take all these leftover scrap pieces and maybe make another circle. So maybe, I don't know, 3 or 4 circles. In other words, we can fit, or in other words, this one circle represents one circle out of a possible total of 3, or maybe 1 out of 4. If it was 1 out of 3, that would be about 33%. If it was 1 out of 4, what would that be? 25%. So when we are done our calculations, our final answer should be very close to one of these two percentages. If it's not, we've done something wrong. I doubt that. Let's see this. The percentage formula never changes. It is always the total goes on the bottom. The numerator always represents the information we're looking at. In this case, the shape. We are looking at the shape here. We are going to find how much space is covered up by this shape. What's another word for space in math? Space being covered. It's the area. So we can say it's the area of shape. Of shape. That's my numerator. My denominator is going to be the total space. Or the total what? The total area. Multiply those two by 100 when you're done dividing and you get your percentage. That's it. It doesn't change. No matter what you do with percentage, it's always the same formula. Total on bottom, your subject goes on top. Now in this case here, look at the area of the shape. What is the shape? It's a circle. How do we get the area of a circle? Oh, I know, Mr. Mellum, it's base times height, right? We've done it all the other shapes. Not so fast. Okay, well maybe it's got to be base times height divided by 2. No, that's for triangles. We haven't learned the one for circles yet, so I'm going to teach you right now. You find the middle. You draw a line to the edge. That line is called the radius, which is the distance from the center to the edge. You measure it. It looks like it is 1.6 centimeters long. Then you multiply these numbers. Now follow this. The area of a circle is the number 3.14. Don't worry about where that came from yet. We'll learn about that later on in the year. Take that number 3.14 and multiply it by the radius, which was 1.6. And then multiply it by the radius again. All right, if that was a different number, then that number would go there instead. You multiply all of those into your calculator, you get 3.14. Multiplied by 1.6, multiplied by 1.6 again, and you get 8.03, which is about 8. Let's round it. 8 centimeters squares. 8 centimeter squared. That's the area, so that's going to be my numerator, the area of the shape. Now, the total area is going to be everything that's black. And what shape is that? It is a rectangle. Base times height, right? All rectangles have the same area formula. It's always base times height. So let's go ahead and measure that base. The base looks like it is exactly 8 centimeters. There it is. And my height, if it's the same as my last example on triangles, it should be 4 centimeters, and it is. So we have a base of 8. And we have a height of 4 centimeters. Tell me something. What's base times height in this example? 8 times 4. 32 centimeter squares. Times that by 100 when you're done dividing. Now look, I can reduce 8 over 32. It is exactly 1/4. But if you didn't know that, you can just go 8 divided by 32, multiplied by 100. Look at that. 25% is what we get. So our percentage is going to be 25%. We were right. We estimated that one circle would be 1/3 or 1/4, and 1/4 it was, which is 25%. Our estimate was bang on. We did a great job, in other words. Now, if I changed this design, and instead of one circle, I drew two circles, two identical circles, and I asked you what percentage of this rectangle is being covered up by these eyeballs. Hey, we can even make them fancy. We could make eyeballs, make them glasses. What percent is being covered by these glasses? Forget the earpiece and the nose piece there, just the circles. Well, we would know that one shape is 25%. We would know the other shape is 25%. You put those two together, you get 50%, which is 1/2. 50 over 100 is 50%, which is 1/2 of the design.